Hello and welcome to Codebase Alpha episode 75, and it's a shader stream today, and we're going to do a bit of work on the shader we started last week, and then do some another shader, hopefully anyway. So that's if we get to the tasks, we should have a couple of shaders finished for this evening. So let's go straight over to our pair programming scene and join Mårten over there.
Hello.
Hi there, Mårten. How are you?
Yeah, I was just amazed by the production value on the.
On my little trailer there.
Yeah. I like it.
Thank you. Yeah, it's that was kind of a morning's work, so and it's like 2 minutes long, and it takes 3 or 4 hours to get that kind of stuff together. But I was quite pleased with it. Okay,
Yeah,
so
I mean, I can totally see that it takes a little bit time. It might not be that many seconds, but getting everything right, getting clips together, and sort of making it look decent. That takes effort.
yeah, it's quite a good program. I use something called Power Director, so it's got some good features to it. So it's quite easy to use. Which I often find a lot of these video editing software is quite hard to use, but it's quite easy. So,
Can it export the video as the Sprout format?
I'm not sure because I tend to use it just to export up to YouTube, but it might be able to. It does quite a few different formats.
If you go into Kodelife here, if you go into the preferences here, edit, I believe this.
Right.
And then you can say output if you click that thing there. Scroll down.
Oh yeah,
you can export. So what you can do is you can export the shader as a spout server. So if this tool could sort of pick that up, you could actually incorporate the shaders into
directly in, yeah. Because at the moment I just kind of I do a screen capture on it, so it'd be nice to get it directly in, yeah.
And also, what you also can do here is we haven't looked into that, but you have the shader stage that's the upper right corner. If you click the shader stage there, and then you click the plus button at parameters.
Okay.
Constant, is it? I don't forget.
Shared image. Or video here, yeah.
That's a spout. Now, video is a normal video file, but shared image is a spout server. Then you are a spout client, so you like importing these images from a spout server.
Right.
So then you can sort of, if you have a video editing tool that sort of renders video, you can sort of bring it in and do stuff with that, and then sort of send it out again using another spout server and be capturing it. So there are things like that people are doing. I've been seeing.
Interesting.
So you can do all kind of funky stuff.
So this is how far we got. So I added a little kind of rocket motor to Alf, so he looks a bit more kind of funky now.
Realistic.
Yeah. So let's just start it off and see him fly up screen. So
waiting for it to happen on the
here he comes.
Stream.
Here he comes.
Yeah. So when I do the screen sharing, it's unfortunately I have to wait for the stream to catch up, so I can see it in its full glory.
Hello, Dragon. Welcome to the stream. Good to see you. Have a salute to Alf. So yes, that's how far we got last time, and I guess what we were going to do is we're going to try and get this into a web page, weren't
we? Yeah. So an idea we discussed last time was that we should make a new Codebase Alpha, sort of, like this Electric Alpha, right?
Yeah, like this.
Because Electric Alpha is just it's just a web page, really.
Yeah, this is so we got this is Hyperspace Hype here, and I'll show you Electric Alpha as well.
Yep, and so one idea could be that we make a new one for, I don't know if this is a raid thing or whatever, that you can use on the stream.
I think it'd be great. Yeah, that's a nice raid one would be good, because that's one we haven't got.
So what you're using here, which the stream viewers might not know, is this is actually hosted by me on GitHub under my mrage github.io, But I think it's better if you create your own
Absolutely.
postal, and we can sort of create it there. So if you so this is a little bit tricky to get right. So we might need more than one try.
Okay.
But you do it on GitHub, I believe.
Okay, here we are, my GitHub. Sorry about the blinding white light.
Yeah, it's good. It woke me up. And then you create a new repository. And I believe it's as simple as making sure that repository is named smb.github.io. I will share a link with you so you can see why I think that is the way.
Okay.
So a little second here. This multi-factor authentication is good stuff, right? But it's always irritating. I have to log in.
Okay, so I've not tried this kind of thing before, so that's interesting.
Yeah. So let me share this thing here with you here.
You're putting that to code share, yeah?
Yeah, if I just find the browser.
Okay.
There we are. Now I'll share it with you. So if you open that thing up, or whatever, how you say it. Paste and go. Okay, that's a good one.
Go.
So this is
okay.
This is the GitHub repo. So I think what you need to do is just make sure that your repo is called snb.github.io.
Give that a go.
And you give it a good name. It obviously needs to be public and these kind of things.
Yeah. I don't know what to call it really, but we can change it.
Coded Beard, hello there.
Sorry?
Coded Beard joined the stream.
Oh, Coded Beard, welcome. Good to see you.
He's a Twitch Primer. Am I Twitch Prime still? Oh, yes. I got 3 badges. I don't even know what they're doing.
Yeah, you've got a mod badge. You got a founder's badge and Twitch Prime badge.
Oh yeah.
Yeah.
I will add that to my CV.
Your CV, yeah. Okay, there we go.
So you clone this thing here.
I'm just reading what we got here. Okay.
Yeah. Usually what I select is like to get the README files. I don't have to answer all these things.
Yeah.
We import code from another repository. Well, maybe just import my code. That's let's go back here.
Yeah, I don't think I want to do this. So let's go back here.
So
GitHub.
I think it's created now, right?
Oh,
or
right.
Maybe it didn't. But but let's try it. Let's try to create it again. And then you.
Yeah, it already exists. So let's get rid of it and we'll try again. So we'll go back to here. Repositories. Delete this.
Or I don't think it. Yeah, I don't get this way they have.
No, I don't understand what this is all about.
But I think it might be as simple as you just clone this thing here. Just clone this repo. You have the URL there.
Yeah, I can't see how to clone it.
Setup. You have the URL there. Quick setup. If you've done this kind of thing before.
Oh, okay.
And then you have the URL that you can clone with.
Okay, let's just clone it down here then. Bit of cloned into empty repository, fine.
Yeah, and in this empty repository, we create a file called index.html. If you go into that repository, maybe open VS Code here as well.
Yeah. Index.html. Yeah.
Yeah.
this one. Nope, that's featured chat. This one here.
And here you just make a simple hello world HTML. I think you can just type hello world and it's okay. It's certainly not the best one, but the pudding.
Oh, the pudding's here. Oh wow. Welcome.
Save this thing here.
Okay.
And you commit this as your first commit. The root commit.
Initial commit. There we go.
Yeah. So they have some kind of caching on this thing. So often it's not available immediately. So we probably have to wait a little bit to see if something happens. But then I think we should be able to browse to this web page in the web browser smbgithub.io, and you should be able to see after this push, of course, yes.
Yeah.
After a while, you should be able to see an hello world. But while we're waiting for all that kind of caching to be updated, we can copy an example that I have created. So what you can do if you want to, you can clone my GitHub.io here, and I prepared like a chef. I prepared a little bit example. Okay.
Let's clone this then.
Yeah. So most of junk in this repo, but this repo contains, among other things, your SMB.
Oh right.
Yeah.
Oh, we've already got it, I think.
Oh yeah. So then if you go into that thing there, and you go git pull.
Okay.
And you go into a folder called diversion, because these are diversions. That's where I spend all my time, by the way.
Okay.
Rambling Geek, hello.
Rambling Geek, welcome to the stream. See you.
So if you go into SMB here, there's several, but I think the first one. And you open the indexed HTML. I think that should work. Oh yeah, I was thinking of type index HTML to open it in Edge. Is that how it works?
No.
Or maybe you have to type open. I don't know how that thing works anymore. Okay, if you trust this command, type / okay, try it.
HTML. There we go. So that's our electric. So that's probably wrecking the stream at the moment, but it doesn't matter. That's our hyperspatial hype, which I absolutely adore.
Yeah, that is the. I don't know if it directly streams, but it certainly wrecks Microsoft Teams.
Yes, I bet it does. I'm going to shut out of that one because it's. I think it does actually. There's so much going on in there that it.
Every pixel moves.
Yeah.
I don't understand why they haven't introduced Julia fractal compression algorithm. That would be perfect, I think. But if you go to SMB3 instead, that is more manageable.
Right, let's have a look at that. Oh, okay.
So this is a very, very simple shader that just has the noise texture. We need a noise texture, and has the SMB. Hello, I don't know which one is this called.
This is hype.
Which is hype, yeah. And I just add the noise on top of the hype to get. And it turned out pretty okay, I think, actually.
Yeah.
Surprisingly, with no effort. So I think we can use this thing here to start creating the new raid warning, or whatever you want to call it.
Okay.
For you here. So I would suggest copying this thing here. You can give it a better name if you want to, but copying the whole directory into your GitHub repo.
Okay. Let's do that then. So, okay. Here. Where are we? There. And that was in diversion SMB3, and let's grab that lot. Okay, pop that over into mine, which was here.
Yeah.
There.
There's also a very interesting rfont.png, which I'm hoping to get to later today.
Cool.
Yeah.
So do we want to have our Rocket Alf image in here as well?
Yeah, we're gonna do that. But I will put them not on the root level, but in a subfolder,
Okay.
so you can have several of these.
I'll call it RAID. Okay.
So go in and we click through index.html. It should still be working, right?
Yeah, it's working fine.
I got it correctly. It should just be. So shall we have a look at how this thing works then, and talk a little bit about that?
Yeah, let's have a look. Okay, there we go.
So if you open the file folder, we should see. If you see the file tree, right, on the left side.
Yeah.
Okay, no folder. Open folder. Can you do that?
I'll do that. Yeah.
Yeah.
Open code. There we go. Okay.
So the index.html is the entry point, obviously.
Yeah.
If you have, so we can click on that and have a little bit look. And it's blah 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 blah. And there's some simple style sheet, and here comes the fragment shader. And the first bit here, begin and comment, the prelude part, right?
Right.
The purpose of the prelude part is to make the code below be shaded toy compatible.
Right.
So
okay.
this thing just sets things up so that it's compatible with shaded toys. So the idea with this thing is, at least I was thinking, like, yeah, then I can take a shaded toy, cool looking shaded toy, that found a shaded toy, just make it into a web page.
Yeah.
It's not 100% correct in that case, but it works pretty good. So that is just a common prelude where you don't have to look at that. And then you have the main image function that is, it takes a frag coordinates input and produces a frag colors output. And in this case, the only thing we do is we sample the texture from channel 0 and sample the text from channel 1.
Yeah.
And add them together. That's the only thing it does. And we're done. And then we also have a vertex shader, but we don't. It doesn't do anything. The vertex shader, because there are no vertices. As we talked about before, there are only two triangles here.
Yeah.
When we're rendering the image to create a quad or a rectangle, so there are no vertices here, almost. So it's only in the fragment shader. So but before we start messing with this thing, maybe we should just commit this code here.
Okay.
So I would actually restore. You removed. Yeah. So you add the diversion. The rating, right?
Yeah.
You see, you remove the file here. I was thinking we shouldn't remove that file. We can take it back.
Which file?
So if you go git status. You
deleted the index.
Index.html. So if you go reset on that thing or whatever it's called, git reset index. Is that how you do it? Ambiguous argument, unknown revision. That's interesting. So, but okay, let's do it again. So go git reset. So we start git reset.
There we go.
And then you go git add the RAID, just that folder. And then you go git commit. And then I will go git checkout to get back the file.
We want to push that up to the center first.
But I was thinking you have a file removed now, so if you go git checkout first, we get that file back.
Okay.
Or git checkout .
Okay.
Now you can push.
That's back
It
now, yeah.
wouldn't make any difference, but now we have the file back.
Yeah. Okay.
So if you go to this site now, I think I tried it before. So if you go to in the browser, you go to smb.github.io.
Okay. There's the hello world, and we go to RAID, yeah?
And we go to RAID. Hopefully it has refreshed the cache.
It has. There it is. Wow.
So that's the one way to sort of create small static web pages.
It's really easy as well, isn't it?
Yeah, yes, it's really easy, and it's it's obviously all in GitHub, so everything works, and and since these pages are kind of very very static, hosting here on GitHub works very well for my shaders, because shaders are just client; they are no server side.
So yes, Jag and I, a little bit of Git there for you.
Yeah. Yeah, Git. Yeah, I actually struggled a lot with Git in the beginning.
I think there's just so much you can do with it.
Yeah, but I think for me, Git, I started to understand, and this sounds very weird, but maybe that's how my brain works. When I understand data model in Git, how it works internally, now I just tend to think how I want to transform that object tree into another object tree,
right,
and then operation. So it says it's very detailed thinking. Maybe not the best thinking, but it works for me at least. Yeah.
There we go. Yeah.
So let's see if we can make this a rocket then.
Okay, so I can drop my we can drop the rocket elf.
Okay, but there was actually one thing I want to look at first.
Okay.
We can talk about first. It could be good. So if you go back to VS Code.
Yeah.
If you scroll down a little bit, we set up the texture share. So you see the image 0, image 1.
Yep. Yeah.
And they are collapsed. They have no visibility. The only reason we have them there is to get a web page to load these images for us.
Right.
And then when it's loaded, we will start the shader. Then we run the start function. So they are just here to load these images. They are not here to be visible.
Okay.
But then what happens if you click on webgldriver.js?
Oh, this is the magic, isn't it?
Here is the magic sauce. So what this thing does, it does a lot of things. But what this thing does here, if you scroll down a little bit, the magic that's happening here is, you see line 49.
Yeah.
It grabs the GL canvas, and that is the canvas that we use to sort of paint there's a normal web canvas we're using here.
Yeah.
So then we're grabbing that thing, and then we do init webgl. So if you go to that function, I just want to show you a little bit what's happening here. It says canvas.get context experimental WebGL. There are different versions you can get WebGL to. This version is experimental WebGL. So what this thing is using, from the canvas, we get an OpenGL context.
Right, I see.
Yeah. And there are different contexts that exist.
But this is all the magic of HTML5 then, isn't it?
Yeah, I guess so. And then from this OpenGL context, here you start seeing init buffers. You see it start doing a lot of vertices and boring stuff. This is just to set up the triangles.
Yep, so they're drawing the triangle, yeah.
Yeah, and this code, by the way, if you look at this code, this is like taken from, it's more or less exactly how it looks in their documentation, but in JavaScript rather than C.
Yeah.
And the bind buffers, and this is just, in my head, this is boring code. The only reason I write this code is so I can write my shaders.
Yeah.
And then I never kind of modify this code. because it's static. It's always the same. But what we also do here, which we need to in this case, it's okay. But if you search for texture 0, so here we create a texture from the image 0
right,
and
okay,
1.
yeah.
And then later on we're going to use them. So if you search for texture 0 again,
Delta 0. Get up to texture.
Here's handle texture loader. So it does a lot of MIP mapping and clamp to edge. There are also different kind of clamping strategies. We don't have to get into those things. Let's search for it again. What I'm looking for is the bind function.
Yeah.
Here's the bind texture, right?
Yep.
So let's find when bind texture is used. Yeah, we have draw scene. This is what's called every frame. That is drawing the scene. That can be interesting to look at. So if you scroll down here, so draw scene, we start by clearing. If you go down, you were in the draw scene function.
There we go, draw scene, yeah.
Yeah. So this function started line 214 by clearing the image or the texture or what's the represent image.
Yeah.
And then it set up the vertex buffer, the vertex texture core buffer, the normal buffer. We don't care about those stuff. They just need to be set up. And then we set up the textures.
Yeah.
And then we set up the shader then we set up these parameters called resolution and time.
Yep.
These are the uniforms in the program, and we set the resolution to the width and the height of the screen, and we set up the time. The time is advancing, and then finally we go draw elements, and we just draw 6 vertices as triangles, and that becomes 2 triangles at line 232, and then we're done.
Yep.
So this is just to sort of prepare for drawing out shaders, but this is kind of the same for whatever shader you make. You have to tweak a little bit sometimes, but it's kind of the same for everything.
Yeah, I recognise the concepts in there from the GLSL tutorials on the internet. So exactly the thing. They start off by drawing the 2 triangles. Exactly what they do every time.
But what I want with this thing is just that I want something that set up everything for me that I can copy paste everywhere, and then I can just tweak on the shader in the index HTML to my so the way I want it, because that's where I want to spend my time. I don't want to spend my time in here because this code is just configuration. It's just setting up the fun stuff.
Yeah.
So shall we try to do the rocket then?
Yeah, let's give it a go. So
if you take the index HTML, here we have the rocket. So we can take this. So what you do here is you if you copy this, not all of the file, but a lot of the file. So what you want to copy is the noise function and everything below, I believe.
We don't want the main, do we, at the moment? We can have the main, I suppose. We can just change it.
We need to change it so it's compatible with. But we can fix that. And you go back here, and so let's put that between the main image function and the prelude function.
Yeah.
Or maybe, I know it's probably a good idea. Let's do it this way. So we have a noise function, we have the FBM function, that should just work. We have the polar chords function at line 80 and below. That should just work. The rocket plume function, I don't think that what we need to change is the main function.
We also need to go and change these texture zeros, do we? Or are they okay? They're not I channels anymore, are they?
They might. Let's look. You're probably right about that. Let's look at that thing. So it's a texture 0. So if you scroll up.
Yeah. I believe this is probably I channel 0, isn't it now?
But it's also I channel 1, if I remember, because I think I load SMB.
Oh, okay.
0. So if you type I channel 1 here.
Okay.
And then you find the text. Oh yeah, every place you're using this text function.
Yeah. Texture 1 here. This will be I channel 0. Okay.
And that's it.
I think that's it.
Yeah, and then we have the main image function here.
Yeah.
So we're going to change that. So if you take, I think basically what you do is you take the signature of the I will just take the signature of the main image function at line 159 and replace the line 144 with that. And we can start thinking how to do it. And then you remove the rest here. So instead, if you scroll up a little bit,
we should have we have time involved here, so and resolution. We need to change these, don't we?
Oh yeah, we need to change
eye resolution.
Yeah, eye resolution. Yeah. You've done this before, I hear.
Yeah, so I'm pretty good at converting to shader toy now.
Yeah, because this is made to be shader toy compatible. The functions are, and these things are named shader toy.
Doing eye time in there. More times. Don't think there's any more. I think that's probably it.
Yeah, you see, you have frag chord here. Frag chord should be copy paste and replace in data vtext chord.
Frag chord here. What's it going to be?
You replace line 146. You replace the in data vtext chord there.
Okay.
And you have a time there as well, right?
I do indeed, yes. My time.
So we save this thing. We see what happens when it. We're not going to get as nice error messages as we get when we do other things, but we get some. We're going to get something. So you take up the web page where we had this thing. Yeah, you can do it like this. Yeah.
So okay, so we've got it's texture. No matching override function found.
It's called texture 2D.
Okay.
For some reason, I think texture is a macro, and that is not defined here. Not sure why. So you search for texture parentheses, and then you place here like the texture 2D.
Texture 2D. And it should be there. Okay. Tan-H.
Well, doesn't tan-H exist? Let's look at tan-H. If you search for it, it could just be that we are having search for tan-H.
Yeah, I think I know where it is. There it is. There. We could just try and lose it for now. Yeah.
So you can try what?
We can try and just remove it for now.
I try to remove it for now. I'm a bit surprised by that, though.
Yeah, I imagine it'll be there.
Keep the parentheses. You can keep the parentheses.
Okay. Let's give that a go. Okay, it's not appearing.
Okay, so if you click what's called the debug mode, let's see if you got some console error messages here. No, not really. That's a suggestion here. Maybe we should take the shader toy, the thing you made for shader toy. You made this thing work in shader toy, right?
Yes, I did. Yes, so I can go and grab that. Certainly.
Yeah, because that works. We know that.
Yeah. Okay, let's go and do that. So that's obviously using a different image because I couldn't upload our alpha image.
And and that's the benefit of doing it. What we're doing here now is that we can actually use it here.
Yeah.
So, but we need to flip the
set the images across. Okay.
Yeah.
Right. So this is going to be channel 1.
Yeah.
And this one down here is channel 0. And we needed to look at the tan, hyperbolic tan.
Let's try. Let's just
try it with it. Okay.
Yeah.
Yeah. So There's the texture thing again, unfortunately.
Yeah.
So, do that.
Let's look up here. Let's also look at the top up here to see if it says something about the version we're using. Yeah, you can do it here, right? That's correct. But if you scroll up a little bit,
okay.
It doesn't say anything about the version we're using. Okay, so that could be an input that we could set up.
Okay.
Maybe I'm doing it. Okay, but you can scroll down and we please rest.
Texture. Where are you, Alf? There he is. 2D. Okay. Yeah, so it's 10H again. So the version.
Yeah, let's just see if that is something. So if you go into into the program, the search for hashtag or hashtag version in the WebDriver JS. See if that is defined.
Hashtag driver version.
Yeah, just version. Hashtag version.
Version, no, nothing there.
No, it's not defined. Okay, let's see if you can define that and see if it works. So if you go into index.html,
okay,
and use add hashtag version above common prelude at the top. I think actually right there.
Yep.
If you type hashtag version.
Okay.
150, for example. See what happens. I think it's going to complain, but we will see what it says.
Version number not supported.
Oh, okay, that's okay. Let's remove the 10H function now. What I usually do is I leave the web page up and I just reload it.
Yeah.
You don't have to. It's interesting that the 10H function is not existing.
Okay, version 150 not supported.
Let's go with 100, 120 perhaps. I'm just randomizing numbers here.
Okay. Nope.
Okay. Well, let's remove it altogether.
Okay.
It didn't seem to help with the 10H. Maybe. Well, let's see. What are OpenG? Try 90. This is
90.
Yeah.
Okay.
Still black.
Yeah, it doesn't. It's not that.
Okay.
I'll get rid of it.
Well, let's remove this altogether then.
Okay.
I was hoping that could give us access to the 10H function.
There's probably something we can do there, I should imagine, but I'm not quite sure what.
Yeah. So go back and refresh the page.
There he is.
Yeah. So yeah, it's not perfect. I mean, but there's something, right?
Yeah, we got something pairing.
So, oh yeah, the reason the file looks wrong is because we are using clamp. We are not using repeat. So we need to change that.
Right. Okay.
And Alf is upside down.
He certainly is, and it's the wrong Alf as well. So.
But let's fix so we have the right Alf. Maybe you should say this anyway. I mean, we had some progress.
Do you want me to push that up onto Git? Yeah.
Yeah. Okay. We don't have to push it, but we commit it so we can mess up and get back to this. I mean, it's always better to have something on the screen, I think.
Yes, than nothing. Yes, we had a black screen otherwise.
Yeah, because that you can always work when you have something. When you have nothing, it's hard.
This is cute. What do we put for the commit message? This is always my problem.
First horrible.
Yeah.
First semi-working version. I don't know.
First working version. There we go.
and you
need to get
up and you add it. Yeah.
There we go. Okay.
That's good. Okay, so let's bring in the proper Alf.
Okay, we can do that. So he lives up here now. Rocket Alf, I think it's called. There he is. Rocket Alf 2. D.
Now the question is, what dimensions is it on that picture?
So he's about 171 square, I think, this particular Alf.
We will see what happens.
Yeah.
Because I think I put on MIP mapping on these things, and then it probably wanted to be square, like 512.
It's definitely square now. So this is a square image.
We can try at least.
171 by 171.
What is SMB? How big is that thing?
That's 128 by 128. So this is slightly bigger.
Let's see if this works.
Okay, so we need to go
then you go back to index.html and you replace this with what's called Rocket Alf. Reload the page. Yeah, I think the reason it doesn't work is because it's not power by 2 size.
Okay.
Because the reason for that is because it uses a MIP mapping, and MIP mapping, that's a special technique, but that requires the size to be 1. We can turn it off. You see if that helps. Probably don't need it.
Okay.
So if you go into the source code here and you go into the driver.
Okay.
And we find the place where if you search for MIP map.
MIP
map nearest. So if you go linear instead, so you remove this linear nearest. Actually, I think you can just remove the generate MIP map call at line 200. When I think about it.
Just remove that.
Yeah, and maybe you replace linear MIP map nearest with linear in both line 100C. I think that could do it. Let's see what happens.
Here we go. Fingers crossed. Yeah, there he is.
Yeah. So the problem is that MIP mapping. What MIP mapping does is that it takes the image and then it creates an image of half the size that is scaled down, and then it does it again and again and again, and then the hardware picks the correct texture depending on the zoom level, kind of the image.
Right. Okay.
Yeah, but this is something we don't need it here in this case. It's a little bit useful for the flames, but we don't really need it.
Okay.
Now it's also upside down, but that's easy to fix. We just flip the x-axis on it.
Yep. So that's Alf here, and we're multiplying.
Yeah. So. Yeah. So where do we do it? So just before we sample it, right?
Yeah. I think it's.
No, I think we should do it right before the texture thing.
Yeah.
Because if you look at in the L function.
There, yeah.
So here pos. So we want to make sure that pos y is, if it's 0, it should be 1. If it's
yeah,
we want to flip it in that way. So what do we type? We type pos y equals -0 1 minus pos y. That should work kind of, right? Shouldn't that kind of work?
Looks like it should do.
Advanced mathematics.
Yeah, very advanced. There we go. Let's see. There he is.
Oh, look at that. Now the flame looks kind of weirdish.
Yeah, like
and
a feather rather than a flame, doesn't it?
Yeah, I mean it's kind of coolish.
Isla with Trainwalk, welcome to the stream. Good to see you again.
From Dragon. Sorry, I missed that.
Yeah.
Can you save that script as a JS file? Then you will get the syntax file, GLSL file.
It's a web page and it's a HTML file.
Maybe if you could maybe import it, but I haven't thought about that way. We can look at that later, perhaps. See if that works. So I think the reason it looks funny, this flame here, is because it's clamped. That means that it's when we go outside the image.
Yeah.
Then we get we don't get the
just
texture.
Repeats, doesn't it? It doesn't repeat right. It's just like the same pixels all the way across. So yeah.
Yeah. So what we want to do, we can either turn it on in when we load the texture, but probably then we turn it on for ALF as well, because we have the same function. So we can sort of just implement this in the noise function. Hello there, Dominic Streaming.
Dominic Stream, welcome to the stream. Not seen you before. What we're doing? Yeah, so we're working on pixel shaders. So we've done. This is like part 8 of the series on pixel shaders. We started off, many weeks ago, with a simple kind of 2D kaleidoscope style shader. I'll kind of recap the shaders we've done. Let's do that now. As you're asking the question, there might be other people who have not seen these streams before. So we kind of started off. It was probably a couple of months ago now with this shader here. So we're on a shader toy at the moment, just as a place where I can demonstrate these. Then we quickly moved the next week to ray marching, and this is a 3D ray marcher. These kind of soft spheres colliding. And then we did once again another ray marcher with these this kind of highly reflective surfaces. And you can notice here that the sphere and the cube are more reflective than the base that they're kind of rotating on. So that's kind of an effect. Also, there's dual suns. There's 2 suns that it's rotating around. And then we kind of moved on to doing things like this, which is a terrain shader. This is the latest version of that. Actually, I can show you that. So yeah, this is our kind of piece de resistance at the moment. So we've got
just point out here for Dominic Streaming, you then have the source code for this terrain shader exists on the web page. So if you
here's the source code.
There is the source code. I mean, it's not trivial at this point because we've been working a lot with this, but we built it up from this very simple 2D shader, which is very, very simple compared to this, and into this more complex one.
And it's all done through mathematics, so there's no polygons involved. It's all mathematical functions and noise textures which are creating this. So the mountains are created by just a simple, I think, a Perlin noise texture in this case. The clouds that move around are I think, a cellular kind of noise. So yeah, that's what we're doing. We're working with these shaders, and the kind of plan at the moment is to create an effect for the stream for when we get raided. We're going to kind of launch our alien mascot Alf on a rocket plume. So this is the shader that we created in Kodelife. So as you can see, this is what we built last stream. And we're kind of using the same code, but we're trying to get it into a web page, a static web page. So,
and the reason this works is because web pages today support something called WebGL, and so this is a program is not in JavaScript, but a program which is called GLSL, which is for running programs on the GPU, and then we have access to teraflops of processing powers. And that you can access that from the web browser as well by having a canvas and then open what's called an OpenGL context and that's what we've been doing here. And so we are porting this thing here. Yeah. This is not a very expensive shader, but not everything has to be super expensive in terms of compute power.
Yeah, so you got to remember with the shader that it's all happening in real time. It's and it's every pixel on the screen is being calculated in real time, 60 frames a second. So yeah, that's the power of your GPU being kind of utilized.
So if that made sense to you, Dominic, streaming.
Yeah, do ask any questions if you don't follow. But all past streams are up on YouTube, so just check out my YouTube. I'll just put that into chat for you. Pop over there, and I think I'm one subscription off hitting 150. So you could go and subscribe if you wanted to, and then you'll get notifications when new videos go up. But we build all these from scratch, so you'll be able to follow along, and all the code's on GitHub as well. So you can go and get the code.
Maybe you should share the Shaded link as well.
Yeah, so we've got a new command, shaders command. Hopefully, should come back. Oh, it didn't come back. Oh, naughty Nightbot didn't. Is it shader? Interesting. I'll set that up just before the stream, and it doesn't seem to have taken. So we can go and get the.
Okay, this is actually boring. Oh well.
Okay, fair enough. We won't bother them.
Can't please everyone, I guess.
Okay, so
I still think it's pretty cool, though.
It is pretty cool what you can do with a few lines of code. You got to remember this is like this is 120 lines of code, and the terrain was something like 250, 300 lines of code to do all that detail. So I think it's pretty cool. Okay, so
so let's look at this thing here. So I think the problem we're having here is that what we need to do is we want to make sure that when we sample outside the texture, we need to go back inside the texture. So what was happening there is we are sample outside the text. We're going so between 0 and 1 is the noise texture, but when we go to 1 and beyond, we get sort of the last pixel of the noise texture.
Yes.
So we want to make sure that is we are sampling this thing here. So if you go up to where you're sampling and using the noise function.
Right, that's that.
So what we do here, if you extract I think what we can do is you just put a mod around pos 0.5 there. And you type comma 1.0. So mod is like the modulus function, and that should clamp this. That should clamp this between 0 and 1. Let's see what happens.
Yeah, as always, you just try it out, see what happens. Okay, it's looking a lot better. There we go.
It looks weird. I mean, something is not right, but I mean, it does look better, right?
Yes, a lot better. We need to make it narrower. It's a bit kind of spread out, isn't it? It's everything's very fat, isn't it?
It could be. It looks like the dimensions are wrong.
Yeah.
So one thing we can. This is a part that is a little bit tricky. I remember that now. So, but one thing we could do is we go into the WebGL driver.
Right.
And you go to the top. Let's go down.
Okay.
Here, yes, I think we have max width there.
Yeah.
No, I think I see actual height, width height. Let's see where are these things used? Math round, max width. Yeah, I think. Let's see. I think if we let's say that actual width is equal inner width. We remove this thing here with the max width and these kind of things. So what I'm thinking about it, the reason I added this code at some point was because to limit the resolution on the screen. But this was for sort of expensive shaders. But these shaders are not expensive.
Right.
So just to sort of make this code work, just replace this expression here with inner width. And then you go inner height.
Inner height, okay.
Yes. Let's see what happens when we refresh the screen. The dimension looks better now, right? Don't you think?
I'm just going to see it again. It's still to me, it's still squashed, and it's the rocket plume is spreading out a lot more than it should. Really, we might have to adjust that. Needs to be,
right.
yeah.
I was hoping it would look a little bit better. Why is that? Let's inspect the canvas size. So if you take up the debugger, we can look at the size of the thing, right?
And we got some invalid arguments as well.
Oh, yeah, maybe that explains it. But it's 248.3. Maybe that is the answer.
Let's have a look.
Bugs in the code.
248. That's this one here. That's
but that's
not that, is it?
No, that's not it. Let's see, where do we bind the resolution? If you click WebGL Drive, if you click that link there, what do I say then? It is saying that.
It is saying that, yeah.
But that is working, because if that didn't work, we wouldn't see a thing. Maybe it's the vertex shader. No, it's not the vertex shader.
See, it looks okay now here, you see, doesn't he? So
yeah,
I think it's just.
But it picks up the wrong. What if you shift click these things? We refresh the. I can try it on my machine.
Okay, go.
If you push this to if you push this thing up. I also wonder where this blue line is coming from. You see the flames are a little bit bluish. Anyway.
Push.
You need to. Did you add the rocket alpha as well?
Yeah, I did, yeah. So it should be up there now.
So, what happens if I go SNB? Hopefully, I don't disturb you too much by typing this. That was wrong.
Finding that it's the kind of the resolution is it's making it too fat. That's the problem, I think.
Yeah, I wonder if it picks up the wrong dimensions. And I remember I've been tinkering with this a little bit before. Let's see how it looks on my screen. Yeah, the same problem. Really.
Yeah.
Other than that, it's okay-ish. There are some blue streaks on the screen, which I don't really understand why that happens. Interesting. Do I get some errors in this thing? unexpanded start tag. I have no idea what that means.
Yeah, it's strange.
Well,
it's almost like it needs to be like half the width of this. Needs to be like half the width, and it looks fine. Obviously, it's kind of the width is twice what it should be. I think that's the main issue.
Yeah. So what we can do, if you go back to VS Code.
Yeah.
And maybe you should print the dimensions when we render it. So if you look into WebGL-driver.js,
okay,
and we are setting up the high resolution thing there.
On resolution, let's go and search for that. Yes, with it there, width and height. That's that
so
bit
if you do a console log of width and height there. I think it's a lowercase console.
Yeah.
I don't know. I don't know this stuff.
Console.log width.
Yeah. And also height.
Can I just put comma height? Can I?
I don't know if that works.
No, I don't know either. So I'm going to put console.log.height.
See, I know enough HTML to open WebGL context, and then I don't know enough.
I'm not a JavaScript programmer. No, I never claimed to be. So, okay, let's give that a go.
So if you refresh the screen, hopefully we see some interesting logs here. Okay, so what happens if you make the debug a little bit smaller and refresh the screen again? No, I meant the other way around. So let's refresh the screen.
So they're staying the same.
It's the same. And 900 that's small. If you refresh, if you remove the debugger altogether and refresh the screen. No, like shift refresh or something like that. And then you open the debugger now, and so we see what it says. So you open the debugger.
Yeah. So now it's 1920.
It's almost like, but that can't be right.
Let's make a note of those numbers. So 1920 and 935.
But now it looks kind of okay. Well, it doesn't look.
No, it's not. It's not. It doesn't look. It doesn't look quite right. It's still.
It looks actually. It looks okay on my when I look on the stream. No, not on the stream, but when I look on your screen.
Oh, okay, right.
Through here, it looks okay-ish. So let's think a little bit, right? So if you go into the code again,
yeah,
and you change the width and height to when we set the uniform, and you change that to in the call to keep those things, it's good to have them.
Okay.
But at line 231, you change to 1024 like 1024 because what we're using it for is to sort of create a scaling. So we see if that code works inside the shader.
Mm-hmm.
See if it uses the resolution correctly, or if that something is broken there. Did that make a difference or not?
I can't see it made a difference, to be honest with you.
Okay, but let's divide one of them by 10. Okay. That should make a difference.
Yes.
So it could be that we, for some reason, are not setting this thing up correctly.
Yes, it's not making any difference, that.
No, so that points to that the issue is maybe related to that the resolution is not picked up correctly.
Mm-hmm. Okay.
So shape from our resolution. So copy paste this, copy this resolution here.
This whole thing.
No, this the name.
Mm-hmm. Yeah.
And you go back into the HTML page. Can you search for this thing here?
So that's where it appears.
Wow, that doesn't look. Oh no, something is missing here, right? Okay, search again for resolution, so we see.
There we go.
Yeah, something's missing here, right?
Maybe I cut and paste something out. Did I? Perhaps.
So if you say UV X multiply by I resolution X divided by I resolution Y. And then you go back to a WebDriver and we remove this thing that we hard coded some values there, right? So we remove those hard, because that is the code that code width is the first one. That code there is the code that fixes the aspect ratio.
Yeah, that's right.
So if that is missing, that explains why it didn't work.
I think you're absolutely right. I think that's the problem. So if I grab that piece of code, for example, and we go over to Shader Toy, and we go to, I think we'll find that the same issue is with this.
Yeah, it might look a little bit stretched there as well when you say it. Actually, when I think about it, because I was thinking that it actually.
You can't tell because of that. The rocket plume is definitely too wide. So let's just pop that into Shader Toy as well, and compile that. Yeah, there you are. Much better.
Yeah.
I'll save that. I'll fix the moving it around later on Shader Toy. But okay, so if we should now be able to refresh the screen here, and it should look much better. There we go.
Yeah, but it's not centered.
It's not centered now. Yeah, it's exactly the same problem on Shader Toy. So if we can go and fix that. So we just need to move him around. So
if you were in the right place to do it. So if you go down.
Yeah, it's here somewhere, isn't it?
Yeah, so you go up there. So what you type at line 148, or a parenthesis around when you divide the frag chord here. So parenthesis around that thing there. I think it's as easy as just multiplying this by 2 minus 1. I might be wrong.
So it's kind of it's much better. It's properly sized, but he's off to one side still, so it's not quite right.
Yeah, that's a bit weird. Let's try this in Shader Toy. See if it has the same effect.
Okay.
Maybe you added some code in Shader Toy to sort of compensate for this thing here.
Probably.
Yeah, you had an offset here.
No, the offset's supposed to be there. So.
But the offset is also in the. Let's look at the offset again. This is the far UV offset frag color. Okay, but let's add this when we make the positions between -1 and 1. So.
Yeah, so I just need to bring him across by half a screen.
So something here is a little bit off.
So Alf is. So if we take this away here.
If you pause the image when it's in the screen, so we can see it. So it's not disappearing, because here you can pause the image.
Yeah.
But why is it moved?
Okay, I commented that out there to see what that was. Okay. So it needs to move across to about there. So minus.
Okay, is this? Did you add this code, or how does it look in our original code in
Kodelife? So it's here. So it's there as well, that particular line of code.
So let's look at main image again. Main image function.
So some of these numbers might be different.
Yeah, the text to coordinate. You see it multiplies by 2 here, and so let's look at the code again in Shady Toy.
Okay.
Okay, in Shady Toy. Is this the same code as we have in?
I can go and replace the code, so it's from Kodelife.
So we can try that. So Dragon's Eye say in this down state line right, so you can change this highlighting to file to GLSL, but doesn't that mess up the index.html? We kind of want to because index.html is an HTML file, but it contains a script that is GLSL. So how does that work? Is that smart enough to realize that that is the case?
Change the syntax highlighting. Okay, you can change it. Okay, that's interesting. We'll give that a go.
But this is the good thing about when you're doing this, when you try to make something work in the web browser, right? Because this is the WebGL, so I like to sort of make it work in here, and then when we migrate it into the into our own WebDriver, it should then just work. So if it works here, it should work there as well. So
there we go. Now it's in the right place.
Okay. So let's take this code here and flip the channel thing, because we have maybe we can fix the channels here as well, so it is in the same position, or we fix them in the.
I'll fix them in our.
It's super easy to fix in the other code. So let's keep this code as it is, and we copy paste this code.
What I will, yeah. So
take all of it.
Yeah.
Take all of it. Did you take everything?
Yeah. So this is going to be our channel 1.
No, let's not change it. Let's fix it in the code.
Okay, fair enough.
So if you go back to the WebDriver JS,
just call that image 1. To WebDriver.
Yeah, that's one way to do it. Yeah. Just change it where you are. Image 1 and image 0. That should work, I think.
Okay.
It's even simpler than what I was thinking. Texture 2D.
Texture 2D and tan. Okay. Forgot about those bits.
Yeah, and tan. Oh yeah, and that's the reason it's. Why doesn't tan H work?
No, it should work. I don't understand why it's not working. There shouldn't be a problem with that, as far as I can tell.
We could implement it.
We could do.
It's not super complex to implement. But I need to look it up because I don't have it in my head. Tan H, Wolfram. That's where I go.
Tan H. Where are you? There you are.
What you can do is just define a 10H function, and that returns just the same value you put in.
Okay, do that.
I see how you mean. Okay, now I get the dragon. I was thinking that. And you need to say it's a float v. We've been programming too much JavaScript here.
Oh yes, right. Been corrupted. Okay. Combine the shader.
We copied the main image function from Shader.
Yeah, I did. Oh, I missed it. Huh.
Yeah, I think
yeah.
Doesn't matter. We just copy it.
Yeah, you're right. I did. I was going to keep it. You see. There we go. Yeah, there we are. It's looking great now. So just the
yeah, we have a few problems now. One of the problems is this.
Why has he gone back to that? Because it was that.
Yeah, because we fixed that in the old code, but then we replaced that the code.
Okay.
So now we need to fix it again. But that's easy. It was just a mod.
Oh, that was right. It was a mod, wasn't it? Yes. So let's see if I can remember where that was. That was
Noise function.
in the noise function. Yes. And it was simply mod.
Yeah.
There. Okay. There we go. Much better.
That starts to look like something.
Yeah, that's what I was hoping we'd see.
So, shall we implement the 10H function?
Let's do it.
10H. How do you implement 10H? 10H. I think it's not so bad, right? It's an exponential function, if I remember correctly. Wolfram online. That's where I go for my.
There we got a Wikipedia reference there to the hyperbolic tangent. If anyone wants to look it up.
Yeah, so I'm not sure if we have that. I was looking at my web browser here, but if you go to Wolfram Alpha, and then you can type in the 10H function, and then we can see the definition, I believe. Do we have this? Yeah, it's very easy definition if you have the hyperbolic scene as well, but we might not have it. Wolfram Alpha.
Yep, got
first one.
Yeah.
Then you can type in 10H parentheses X. And here we can see why we like, at least why I like this function so much.
Yeah.
Because it's linear, as you say, around the origo or 0, and then it asymptotically approach whatever 1 or -1. So it kind of it's linear around 0, and then it prevents it from going to infinity. It's close to 1.
It's a really useful function in a lot of things. So we also used it quite a bit in the audio programming streams that we did. So yeah.
Do we have access to scene H? Hyperbolic scene?
Oh, well.
Should we try that?
We'll
Maybe
try
that
it.
works.
Just do sin H
divided by cos H.
We'll try it. I imagine we haven't got it, but we'll try it.
I'm also thinking it's probably not there. But if it is, then it's very easy to implement.
Yeah, so we haven't got Kosh.
But if you saw, we have exponential functions, and we had a more explicit definition using exponential functions. We can just.
So that's that one there.
Yeah. I have to remember that one, but I can have it on my screen, and I can tell you what to type.
Yeah, okay, that sounds a good idea. See on your screen, yeah.
And I sound smart by doing that. Okay, so I think what we can do is we make a float EX. And that is the exponential function of EV. I will call it X now to not confuse myself. So if you change the parameter from v to, or do it that way. And it make float ex equal to x. And then we have the negative version of this thing, which is x here, right?
Mm-hmm.
And semicolon, and then you make, I don't know what's called this, float ex.
NEX.
Or next, that's good, yes. And then you go to negative value.
X for minus x, yeah.
And then you create ex divided by, you can create a sum of these two, so we don't have to compute it. I mean, this is not an optimization, just to save us a little bit space. So if you create the sum of these two, ex plus nx.
Yeah.
And then what you do is you go return.
Yeah.
Ex divided by sum minus next divided by sum. Okay, that should be it.
Right, let's see what happens.
Now it looks almost exactly.
It's exactly the same now, yeah.
Yeah.
Excellent.
Well, mission accomplished. Shall we zoom in a little bit to make it a little bit bigger? Yeah, rocked off.
Zoom in, yeah. We can zoom in.
You multiply by you go into the main function.
Okay.
And you multiply the UV at line 160 by a half. See what happens. Should be twice as big. It's kind of reverse in this.
Yeah.
It's weird, but it's how it works. It tend to.
There he is, twice as big. I like the way he accelerates. It's good.
Yeah. So what you can do is we can do it in many different ways. But what you can do is you can move. Since we made it a little bit bigger, you can move him a little bit.
He needs to move down a bit and bit up it, doesn't he?
Yeah.
Okay, so with those, with the offset, wasn't it? Those are these values, I believe.
Yeah.
So, so I'm not sure which way to go. We'll change that to -3 and see what happens. So I'm experimenting there.
I think it's upside, but just try and see what happens. Yeah, now it goes faster up now.
Yeah. So that looks a bit juddery. Okay, so that was -2 is fine there.
But you need to change the other value to to 1.5 instead of 1.
Yeah.
Something like that.
So he's off the screen now. Good. It's launching. So it needs to go higher.
Yeah, there is also another possibility, and that is that we fade it out.
Yes, could fade it out.
So, and the way we can do it is it's very simple. So we can, if you go back,
okay.
You can also, if you change back to so it says 1, so it starts on the screen, so we see it at all times. And then what you do is you multiply the color now at line 161. You make a new line there.
Okay.
You go multiply col. By smooth stepping. Yeah, so what I would do here is
okay.
I would break out mod I times 10 in a new variable, let's call it time, whatever. And I would also break out 10 into a period. Let's say, so you make a float period. And that is also used at line 156. I would flip these lines.
Okay.
I have an S there, and also have an S at line 156. So, and what you do now is you smooth step, and you take between 0 and 0.0 and 0.5, for example, and you put in time, and that should be it, I think. You can see what happens now when you refresh the screen. You see it faded in.
Yeah.
And that's good if you have a screen that is kind of you know, if you have a screen with a different dimension, then at least instead of just appearing, it fades in. But you might want to have it outside the screen, you know. But you know your dimension. But if I load it on a high screen, you know,
absolutely, yeah.
And then we can also fade it out, and then we do kind of the same thing.
Okay.
And then you go smooth step. You take a new line and you multiply.
Yep.
And then you go smooth step. And I would then type time minus 0.5.
Okay.
To time, comma time. So what this thing does, it's 0 until time minus 0.5, and then it goes towards 1 at that. And because of that, you have to invert this, and you have to go minus 1 minus this thing here. No, 1 minus smooth step. So at lines 163, you type 1 minus smooth step.
Okay.
Like so. I'm guessing, but I think this should work. So it fades in and it fades out.
Okay, give that a go.
Well,
it's certainly faded out.
It's faded out. that mission accomplished. Let's see again. What did we do wrong?
I'll probably type something wrong here. So time minus 1 time.
Just comment that row out, so we get back to where we were. That worked. Okay, so if we flip the lines and we comment, so what we comment, you know,
yeah,
like so. Let's see what happens.
Yeah, that's the offending line. I'm afraid it's not doing anything.
9, 10. It's not really coming back, right? What if you assign color to this thing here? See what happens.
Sorry, say again.
You assign the color. So instead of saying you multiply, you assign it, like so. Because then we will see. It's probably going to be very black anyway. Okay, so you have to put this in a vec 3. So you put that all. So what is wrong here? Seems easy. It's very, very black.
Yeah, very.
So, but I guess if you remove 1 minus this thing, it should be white then, right?
Yeah.
Yeah.
Interesting.
Okay, well, let's experiment a bit here. So instead, if you take time minus, if it remove, if it says 0 instead of time minus this thing here. Now I know. Okay, this is easy. You can go back here. Undo. And it should say period instead of time. Period minus here.
So period minus 0.5.
Yes. So we want and also period instead of the second argument. So these are edges of the smooth stepping function, and that should be at the end when we're running out of the time. So that's what I intended.
And we can go back to multiplying, can't we?
Yeah. And you take -1.
Give this a go.
So what we expect to see is that it fades out the last half second now, if we did this correctly.
Yeah.
Okay, so then we add back the fade in.
Nice.
Maybe we should go a little bit higher. What do you think?
Start him a bit higher?
Yeah. No, it goes higher.
Goes higher. It should go higher, yes, definitely.
Yeah.
Because he's starting off in the right position, I think. So is that just changing the period?
No. To make it go higher, you change -2 to -3.
This one here.
Yeah. No, 23 is probably too much. 3.0 is probably okay, or 3.1. Okay, let's see what happens.
Okay, let's go.
Then it's also going to accelerate faster because it's going to go higher, so in the same time.
That's perfect, I think.
Yeah. I'm going to see how it's on the screen.
We're there, I think. Yeah.
You like it?
Yes, I do. Rambling Geek. So I didn't notice you'd popped into stream. Welcome.
It looks much better on the stream than on.
Yes, I'm just watching it on stream at the moment as well. Yeah.
Yeah, because I think the team server is optimized to sort of send text and these kind of things.
Yeah.
And so it's sharper on the when we use Teams, but it's much more. The frame rate is not as good, but when I watch the stream, it looks much better.
So I may well have Rambling Geek. I'm feeling a bit kind of flustered today because I think I've caused more problems than I should have done by mucking the code up a bit.
So what if you commit the code?
Okay.
And then I can try to see if I can load it as well and see how it looks on my aspect ratio, which is slightly different than yours. To see that we haven't messed up.
More widgets. I'll push that up. Cool.
So I can see if I can reload the screen. I don't think it has refreshed the cache yet. I still get the. Yeah, I have to wait a bit before the cache is refreshed. It still say Electric Elf, and it still looks weird.
Right. Okay.
I wait.
Added bonus on today's stream. We actually got the definition of hyperbolic tangent for you.
Yeah.
Quite nice.
So now you could reference this. I don't know how you do it with your Stream Deck or OBS or whatever you guys talk about it doing this Switch stream, but you should be able to sort of load it the same way now as the Electric Elf.
Absolutely,
right?
Yeah. let's see if we can. I don't know if we can add scenes on stream. I don't want to do that in case it kind of breaks the stream. So,
Okay, yeah.
but certainly, yeah, that's going to be quite trivial. And I can add wires into my stream deck then, and just press a button, and I should launch across the screen.
Yeah.
That should be.
I mean, it should theory citation mark whatever work, just work, right?
Yeah, it should just work. Yeah.
Yeah. Maybe you should copy your other the other SMB things are created for you as well.
Yeah, we'll do. Yeah.
Because it makes sense that you're actually hosting them in your own GitHub repo. I think.
Yes.
And then I'm hosting them. Maybe I get angry with you someday.
And take them away from me. Yeah.
Yeah, or I put something nasty and you get banned. We don't want that to happen.
We don't want that to happen.
No.
So the SMB and SMB2, I guess, isn't it?
Yeah. And the first one is the infinite. I don't know what you call it, but you can call it what you want to call it. Rename it there too. And the second one is the
electric. Yeah.
Electric, yeah.
Super.
So I think you can just push them, and then I can try to see on my screen when it refreshes to see if it works. Because the way I created them, I try to make each folder sort of self-contained. Pros and cons to that, but make it easy to copy stuff. Yeah, I can see what to do now. Infinite almost became inified.
I thought I did a git.add.
You can add a dot there as well at the end of git commit.
Oh, I see what the problem is.
Yeah, okay, yeah.
There we go.
We push it?
It's about to push. There we are, wonderful. So I'll be able to change those after the stream, and then you can
only got a black
move those.
screen in Chromium or Firefox. I can try that as well. Now,
black screen. Oh, right, that's interesting.
Yeah. So that I know that Chromium has some things that they want to make sure that the images are loaded from the right place. We can see if that is the case here. Oh no, I did the wrong thing here. So
yes, that's interesting. So yeah, so in Chromium Edge, you just get a blank screen as well. What you get here? Oh no, that's wrong. That's wrong. That's wrong. That's not what I meant to do at all.
The electric thing, it doesn't look like I was expecting it to look. It looks kind of okay though, but it's not. It doesn't look. It's not the right one,
isn't it?
No, it's our. Why is that? That's weird.
So in Chromium Edge, what we've done works okay. So then we had electric. Oh, that's that one. Okay, fair enough.
Yeah, I mean it's okay, but that's not what we expected. So let me try this in Firefox.
Still like that.
So Firefox works for me, actually.
Yeah, I think if Chromium Edge works, Chrome should work for you. You got a black screen in Google Chrome.
Yeah. Let's try that. Okay, so when I try to run it in Google Chrome and I type smbgithub.com/raid, I get it looks okay for me. Let me try on this Mac as well, so it's not just something that. But I know that there are issues with these things. When we're loading the bitmaps, it can be a little bit peculiar. But
oops, that's wrong.
So Safari works for me, Firefox works for me, and Chrome works for me. I mean, I'm not saying it's perfect, but I cannot, at least I am unable to reproduce that.
What you're saying, Mårten, is it works on your machine, aren't you?
Yes, like every good developer, it works on my machine.
So see, go to that link I've pasted there, Dragon Eye. That should take you to Hello World, and then just put RAID at the end of it and see what happens.
Yeah. It can also be like a caching thing, so it's not fully, cached and these kind of things. I don't know. Let's see now. Why did we get the wrong? Isn't that electric? Wasn't that?
Look.
Electric how? No, I know what it is, right?
Mm-hmm.
I think we made changes in your GitHub repo. In my, it's the correct one, or the one we expected. But we at some stream we were tinkering around with my GitHub repo.
Oh, okay, yes, possibly.
So if you undo those changes and sort of shake it out again, then you get back to that source code, and then
yeah,
it should work.
I can sort that out.
Yeah, just fix it later.
Yeah, I'll just reclone the repo.
Yeah,
that's not a problem.
So what have we done so far?
Well, we've dug into a kind of a part of the a part of what we've done on stream before, in a lot more detail in terms of this getting these things onto web pages, because it was always it's very interesting that the way you actually combined the two images. So this kind of explains an awful lot how to get this to work now. Because I was wondering, how do we on the web pages, how do we get the textures and the images in? Yeah. It's actually trivial, isn't it? It's quite easy. So it's great.
I wanted when we wrote this drive, I wanted to make it. It's not 100% configuration free, but I wanted to make it quite simple to do it. So you can focus on, because what I do now when I create a new web page using a shader, I copy paste one of this, and I think a little bit with it, and it works, and then I commit the code, and I'm happy.
Yeah.
So and as I say, you just add these images, in HTML, and then the WebDriver.js, it loads these images as textures.
I think it's really good to have this, because a lot of people might have got interested in the shaders in Kodelife or in ShaderToy, but to use them on stream, you need to get them into a web page, so you can have a browser source. So yeah, it's excellent. So it works fine for Rambling Geek and Coded Beard. Unfortunately, the missing ear Coded Beard is actually that the image doesn't have his complete ear on it.
Oh.
So that's why he's got missing a part of an ear. But I guess I could go in and try and draw the rest of the ear, but I was challenging enough drawing the rocket lower half of Alf, let alone trying to do the rest of the ear. So that's why his ear is missing.
It sounds so simple, right? Just put a helmet on him, or
it's really simple. I paid good money to have that drawn.
That requires some artistic skill.
Yeah. So he's the artist who did that is I really really admire his skills. He does anime kind of figures normally. That's quite a departure to do Alf for me. So.
But it is like that I'm sure that he looks at what you're doing and thinks, "Oh boy, I could never do that."
Yeah.
And it's not always like that, but we all have kind of different skills and different specializations. So I struggle a lot with music. It's very hard for me.
Yeah.
Graphics, kind of, at least I can do a little bit, but these things, program is that's the thing that comes more easily for me than other things.
It's the same with me, because I do play guitar, and I've been trying to learn a bit of keyboard, but I find it very, very difficult, very hard going. And so I kind of periodically lose heart and stop, and then pick it up again later on. So I don't make a lot of progress in it. That's an unfortunate thing. So Cody Beard thinks he lost his ear in some kind of work-related accident. I think it was a railgun accident during a raid. Blew part of his ear off. Yeah.
So Dragon's Eye, I think I can explain that thing you're saying, that it works when you do it online, but not when you pull it from your repo. And I think if you open up the debug mode, Chrome complains about the origin or something like that not known. Right. And that is because it tries to load the web pages from the disk, and that doesn't work the way I do it there, the images. It has some kind of checking that the image should be from the same origin as the web page, and that's Edge doesn't test that thing. So that's why Edge works on from the file system, where Chrome doesn't work, but it works when you put it on the web page.
Yeah, sounds logical.
Yeah, it's web stuff, so it's always
it's front end stuff.
It's difficult.
I don't know, magic fixes do it all on the front end. I'll just program the back end.
Yeah, but I'm struggling with the very same thing, and trying to get it work, and in the end I just give up and I use Edge. But now they're going to fix that, right? They're going to use Edge Chromium. So
yeah, Chromium Edge is really good. I'm very pleased with it.
Yeah. So we created this page here. Right? We created sort of, as a sidetrack, a GitHub repository to host your web pages for things like this, right? Shall we talk a little bit about how to render text, just for fun of it?
Yeah, that's one thing we haven't even talked about, is it? Text rendering.
Because one thing I was thinking about doing on a stream later on, this is just an idea. It's your stream, so you do whatever you want. But is if we could take in a text as a query string and display it as kind of an electric elf or whatever. But as a sort of thank you XXX for subscribing, and then launch a rocket in the background. I don't know.
Yeah, some nice new alerts would be great, wouldn't they?
Yeah, and we can do them as shader. And what you do then, I don't know if that's possible from your apps. You just load the page, but you pass in a query string, which is the text you want to show.
Should be able to do it.
And then we render that, but we need them to render text.
Yeah.
And that is, and we want to do it using distance field functions, because when you do it using distance field functions, there are many nice properties that comes from that. So if you look in this RAID GitHub thing.
In yours?
No, in yours.
In mine, okay.
Yeah. There's something called rfont.
Oh yes, yeah.
So I would recommend that you create a new product, and we take a look at that thing. And when I say new product, I mean a new Kodelife product, obviously.
Yeah.
Because I only use Kodelife these days.
Yeah.
I can stop this thing here. So.
Yeah. I'm just going to save the shader file.
Yep.
Otherwise, I'll overwrite something else.
Yeah, I get it. Okay, so we will not be able to finish this today, but we can get a start, and start thinking if we want to continue with this thing.
Yeah, absolutely.
Yeah, so pause it. So what you do is you add a texture to here.
So we have parameters.
And I think it's constant.
Yeah. It's a 2D texture.
No, maybe you can just pick one of these here. Because if you take text to one there, right? Or let's just remove them.
Yes, I was just going to remove these.
Yeah, just remove them. It's probably better.
And this is the one we want.
Then you call it texture 0. And then you, as a file, you put in this file just that I pointed out to.
Yeah. And that's in here, here, and there, our font.
Yeah. And now, if you type at line, you make a new line after 26. So you type Beck for T equal texture 0, comma UV semicolon. And now you pass in, what you do is you take, you can, at line 30, remove all this sine and cosine stuff. And put in col there instead, type col instead of at line 30.
Yeah.
And then you create a col parameter, call back 3, yes.
Yeah.
And you initialize that to back 3t.x, for example. T.x. No,
T.x, okay. Okay. Oh, okay. We have an ASCII table.
Yeah, so there we see something. Then you can take T.y.
Okay.
And that's
Got the inverse of it somehow, isn't it?
Yeah, we see different versions of the same font here. So if you take T.z, it looks like that. I don't know what, I think X is the normal one, and Y and Z is some shading things which I've never used. The interesting thing for me is T.w.
Oh, yeah.
And that looks blurry.
Yeah.
But the thing this is blurry, this is a distance field for each letter.
Yes, you can always see that, can't you? As it gets to the letter, it's darkening.
And here we love, well, I love distance fields. Distance fields are the best. So this is the channel that I want to work with to do font rendering. So what we can do now is, okay, so let's sample the W into like a distance. So you take float D equal here. Instead of, you remove back T. Oh yeah, you can do it like that. Float D equals T.w.
Okay.
And then what you say is col is then what you do is then you say you make this ternary operator here. So if and okay, yeah, and then we want to sort of, W is between 0 and 1, but it's a distance field, so we want to make it between -1 and actually we can just take minus, if you take line 29, -0.5.
Okay.
Because what will happen then is things that are inside the what's called inside the letter will be negative and outside will be positive.
Yes.
That's how distance field works.
Yes.
So, and now we say if D is less than 0. No, not the E. What I meant is
you want a ternary, yeah.
Yeah. D 0.5. Then we make it a 1. Otherwise a 0. So now you see, here is now, we can see now the, okay, and we should also change the resolution to 1920 times 1200.
Can't remember what it is. 1280, is it?
1200.
1200.
Enter.
There we go.
So we see the font now. So what's nice about this now is you can zoom this font. So if you multiply the UV coordinate above at line 27 by half.
Yep, so we've magnified, yeah.
And if you take 25, yeah.
Nice.
So this is an article I read a few months back on about how to sort of create textures from very low resolution textures that look high resolution. And the way they did it was using distance fields as well. Because what's good about this thing, okay, it doesn't look perfect, but because of how the texture, you should also make sure that we scale it using linearly. So if you go to shader stage.
Oh, okay, yeah.
And then you change to linear. It's linear.
Totally linear.
Yeah. So what happens now when this gets bigger, it starts to interpolate the pixels between the actual pixels.
Yes, well, we're getting slight artifacts, but it's still pretty good, isn't it?
It's slight artifacts, but the artifacts are actually less problematic when using distance fields than if you would be using, because these letters are actually very low resolution, and they still look kind of okay. Not perfect, but they still look kind of okay. And
Cheers, Alexis. Thank you very much for the follow. Has some electric elf shader. Thank you so much for the follow. Sorry, Mårten.
No. It's okay. Follows are good. So this is one way to do it, and we can even improve it even a bit further by using the infamous smooth stepping function.
Okay, yeah.
So instead of you do this d less than 0, you do a smooth stepping. So then you type smooth step, and then we go minus 0.05 perhaps. I'm just guessing a number now. 0.05. No, an extra 0. Minus 0.05. Oh.
Yeah.
That's not what I intended.
Nope.
I can type.
You type, yeah.
Can I type?
Yep.
It's hard to explain with back and forth where all this should be.
Okay. 0.05, okay.
And then add the parentheses.
Yeah, there we go.
So now it gets blurry. We also get inverted and not what we wanted. So what to do is you just take one minus smooth step. So it becomes white text on black background.
There we go, yeah.
So it gets a little bit blurry, but now we kind of get this a little bit anti-aliasing effect at the end. So if you instead of 0.05, you've got 0.025. So you divide by 2 there, and you do divide by 2 there again.
Yeah, so it's getting a lot better, yeah.
Yeah, less sharper. But we have a slight sort of, it doesn't go sharply from white to black. It's you can tweak these parameters to make it look better. So now, in order to do text, right, the strategy here that we're going to do is we're going to create an array of values that represent the text. And array of values that represent text. And then we're going to write some text and we're going to show it on the screen.
Okay.
It's not hard in principle, because depending on what to do, we select different cells. However, getting it completely correct is a bit tricky.
Right.
And I was thinking with that before the stream, so I'm just going to share that code with you, so you don't have to spend me tinkering with that all over again. But the strategy is not too complex, I would say. It's depending on what the letter is, we are going to sort of identify a cell and use that cell.
Okay, well, let's look at the code, and we can kind of go through it line by line.
Give me a sec here, and I will show you get the code. So I got it on the wrong computer. GLSL. just a little second here.
I'm just going to try something out here. So I'm just trying out something called featured chat. So this is something I'm playing around with and trying out for the first time. So on stream. So.
Okay, I have no idea what that is.
It was just start playing with the you can it's a feature where you can highlight comments in chat and display them large on the screen. So I'll just display the thank you for Tutor XLS for the follow.
The rubbish. There we go.
How you doing?
Yeah, I'm just trying to. It's yeah. my love-hate relationship with what's it called again? Multi-factor authentication.
Yes.
So
yeah, it's great. It's great when it works. Oops.
I mean, it's good when it works, but the problem is I don't have the device on me.
Yeah.
So I need to run and get it. Well, yeah, I don't want to do it. Okay, here it is.
Okay, let's grab all those definitions and the code that goes with it. Oops.
I expect you want to use copy paste here.
Yeah.
So what we do here is there are no strings in GLSL. Like the strings are a kind of a high-level construct, doesn't exist. So we define what is an A, what is a B, what is a C, right?
Yep.
Like a macro. And then if you scroll down a little bit here, then we define an array that contains the letters. And here it says codebase space alpha space. That's what it says here. And then we define this sample text. And the sample text function here gets a position P and will return the distance to the sort of the text here, if I've done this all correctly. So let's call the sample text function instead of the texture function and see what happens. So you can remove this thing here, and you can remove this line 124 altogether.
Okay.
Remove one line too many, I think. Did you?
I did, yes.
Yeah. And again.
Yeah, it's weird that, isn't it? You can see I'm selecting that line. I'll stop there. There we go.
And then you say float d equals sample text, I think it was called. I forgot already.
Sample text. And what was the input? It was position P, so that's just UV.
And then you remove the line down there. Maybe we need to zoom out a little bit. Yeah, you have to go the other direction. 0. Oh yeah, 2. Yeah. Sorry, my mistake. No, 2, not -2. That
yeah, 2. Yeah, there we are. I can see it there.
But why do you see it and it disappears? Or is it just my screen where it flickers?
It's very flickery.
But why does it flicker? That's right.
Sure. Is it this smooth stepping we're doing?
Nah, I don't get it. It doesn't flicker for me anymore now.
Very flickery.
But it's strange because we stopped the time. So nothing really changed. Let's restart the program perhaps. To save. And to wait here, right? So why is there any programming errors here?
Does not like it.
Sometimes we can get. What happens if you change 10 to 20 again? We tinker with it a little bit.
Oh, okay. Yes. Okay.
You know, because now we said, oh no, did we get the texture? No, it said text to 1 there. It should say text to 0.
Where's that? Sorry, I can't see it.
Line 150.
Oh, there we go. Yeah, there we are. And it's not flickering now. There we go.
Okay, so now it says Kodelife Alpha. And you want this to be scrolling, right?
Yes, please.
So
like a ticker tape, yeah.
So one simple way of making it scroll is that you take just the UV position there. When you pass into sample text, you take plus, vec2, and you put in time as the x factor and then 0 as the y. And then you start the time.
There we go.
And you made the scroll text. Obviously, not amazing, but
it's a start, isn't it? Because if we can make it move along like that, presumably we can make it move it however we want.
Yeah. So what we can do is just try to distort the text a little bit, just for fun of it. So we can take this polar coordinate distortion that we did for other things. So we can implement the polar coordinate. We know that stuff now. So
we'll just grab the code from here. It's easy.
Yeah.
We'll grab the 2 rectangles as well. So we've got both of them.
So the idea is that we.
Oops. There we go. So we now got 2 polar and 2 rectangular.
Yeah. So let's see now where we change it. So scroll down, and then you go under UV. Where you multiply with 20, you go. You transform vec to PUV, like polar UV, right? That's so. Vec 2.
Oops.
2 polar coordinate.
It was called 2 polar coords.
Oh yeah. And you have an extra O.
Oh, I do.
And then you go and then you transform PUV into using 2 rectangular chords. Back to UV.
The UV equals that, yeah.
2 rect, yeah.
Okay.
And now if you take PU between these 2 lines, you add the number to PUV.y. Just add something. Plus 1.
Yep, so we go now going diagonally.
Yeah.
And it's interesting because the letters they're kind of sloping as well, so they have transformed as well, haven't they?
I think that's the explanation that we haven't corrected the x coordinate.
Yep.
So what you do at the line 137, you create a new line between line 137 and line 100, and you say uv.x multiply by resolution.x. This is the classic thing. Divided by resolution.y.
Yep, there we go. It's better.
Yeah, now it looks more correct. So what you can do then is you take, instead of taking plus 1, just take UVY instead of 1.
Okay. Okay. Now it's getting interesting.
Yeah, and don't multiply by 20, multiply by 5 perhaps. So it becomes a little bit bigger. So that looks weird.
It's certainly gone a bit beyond in about 2 minutes. You've gone beyond scrolling kind of ticker tape text to this. Yes, that's great.
Yeah. So what happens if you instead take multiply by that thing there instead of taking plus?
Ooh.
And take 1 plus, perhaps something like that. I'm just randomizing here now. So plus. Well, it's strange.
It certainly is.
Yeah,
It's a bit Doctor Who, like the sort of Doctor Who, or the old Doctor Who with the.
But so the thing is this, that because we're using distance fields, we can do this kind of weird stuff and sort of modify the sort of the space, and we get a distance field back.
Yeah.
And we can also do all these kind of things where we are using smooth stepping, so we can have two texts and they can sort of meld into each other, right?
Yes.
Because that's why distance fields are cool in that way, is that they allow this kind of weird effects very simply. Let's multiply, instead of PUY, take X. Yeah, I don't know what I'm looking at. So plus instead of that thing. Yeah, like, no idea what I'm looking at. But that's okay.
Yeah, it's certainly very interesting.
Yeah. So so I mean, it's something, right?
It's certainly something.
And you can then, if you multiply by, instead of 5, multiply by 2, perhaps. Yeah. So
that is like transforming, aren't they? So
yeah,
C changes to an A. Yeah.
We're distorting space kind of here, right?
Yeah.
And in a weird way, and that's why it does that. And so once again, what's cool when we do this using these distance field functions is that it's kind of robust in that sense, to allow us to do that thing. So I like that. And we can also do later on things like sort of, maybe have text meld into each other.
Yeah.
Like in this smooth stepping with spheres. You can do that with text as well and sort of make it meld in. In a probably cool. We could actually try that right now, actually.
Okay.
So if you remove this weird polar coordinate stuff just for a moment, you can just remove this line 141. You can keep the rest.
Okay.
So let's sample the text. So let's take a float D1 or D2. We can call it D2, and we sample the text, and then we can flip. It's the same as above. Basically the same as above, but you put in parentheses around all the around that, and you flip the X and Y axis by using the Swizzle operator. So after that line, you type .y.x. No, not there. After that one, not there. Between, yeah. This flips and Y. And let's look at how this looks. So if you say D equals D2 now, after this line. I was hoping that it would see. If you zoom out a little bit, what happens then? What happens if we start from the top? So if you reset the time. Okay, what happens if you start now? What happens then?
It kind of goes off. Yes, that's what's happened. It's just kind of flowed off to the left, hasn't it? Disappeared.
Okay, but instead, what you do now is you move that vec2 time outside the parentheses there. And remove the plus as well. And then you put it after this thing here. And now you start it again.
Yep.
Okay, so that it looks kind of weirdish, but that's not. This is not the important thing. So let's call it's D1 and D2, float D1, and then you say float D. No, you say float D equals D2.
Okay.
And then you can say float D equals float D1. Yeah. Now what you do is you can take the mean function of these two. So you take mean D1, D2. like we're doing in ray marching when we want to combine two shapes.
Oops.
So now we see both at the same time. But the thing is, if you use the soft mean function here, do you have that?
We've got it somewhere.
We have that in the ray marching example where you use.
So if we go off to shader toy.
You say this. Yeah, you say it.
On here it should be.
Yeah, we have it in several places.
S-min, there it is. Soft min function.
Take that. And you put it somewhere. Now, instead of taking the mean function, you use the soft mean function there. And you type in maybe .5. It takes 3 arguments. So the last argument is how soft it should be. 0 is not a good idea. 5. No, 5. This is too much. Now, if you zoom in a little bit here, I think we can see what's happening.
Oh yes, yeah. When they collide, they're soft merging.
Yes, yeah, so melding is not in it. So if you take 3 instead of 5. No, I meant the soft mean. The soft mean function.
Yeah.
Then,
yeah.
So at least I think this is pretty cool, and that's the sort of the power of the distance field function, is that it allows for these weird interactions between each other.
This is exactly analogous, as you say, to when we did the spheres merging and kind of melding together.
So we can do like I have several things. I'm imagining several things we could do with text that can make it look like, oh boy, this is pretty cool looking with just text. So if you go up here and look into the code, and you look at the array that defines the text.
Yeah.
So what we can do when we having this query string in the future, when we implement that thing, is that we modify the code so that it inserts
text into there,
or we take it in as a texture. We could also do that thing. So we do a one-dimensional texture that contains the text, and then we render the text using that thing.
That's an interesting idea.
And if you take it as a one-dimensional texture, it can be basically the text can be held as long as it needs to be.
Yeah.
So that is one way to do it, I think. If you wanted to go down that track.
It certainly sounds interesting.
So, what do you think? Is this a decent place to stop?
I think so. What's the time now? It's 20 past 10 in UK time, so we've been going fair time. So
talking for 2.5 hours, basically.
It's I'm almost out of drink as well. So I think that's a good start. So we got a good place to jump off to next time to start working with this text, and that'd be really interesting.
Yeah.
In the meantime, I can wire up.
It's in the chat, or at least it was in the chat. I'm not sure it's still here. But we created this new what's called Rocket Alf for SMB's. I don't know what you call it. OBS, is that the thing?
OBS, yeah. So we can show you.
OBS.
So I closed it off.
Yeah, but it's in your RAID.
Yeah.
It's SMB.
Yeah, so this is what we did. So this is now embedded in the web page.
Yeah, and then we could imagine like having like we could add the text here in the background and do something with that.
Yeah.
I'm not sure what, but that is a possibility.
So thanks for the raid or something, and then the name of the raider.
Thanks for the raid and the name of the guy that is raiding you.
Yeah.
What do you think about that?
I think that'd be a great project.
Yeah,
because that's combining lots of different
features. Another thing which I didn't mention, sorry, I just thought about it, is another thing with regard to distance field function. It's very simple to do drop shadows of text, and it's very simple to do outer glow and inner glow. But we don't have to get into that now. But that's also really strong benefits of doing text like distance fields is that all these kind of outer glow and inner glow effects that are usually quite expensive are super simple to do and cost nothing in terms of GPU performance.
Yeah. I've just distributed some. I've got loads and loads of these community gifts in the gift set, so I think some people should have got some of those by now.
Yeah.
I'm not sure what they are, if they're any use to anyone, but I've got loads of them.
Thank DragonEye for the feedback. By the way. Yeah.
Okay, so let's kind of wind up there then. So thank you very much, Mårten, for that stream. It's been really interesting. I say I'll immediately after the stream I'll sort out the electric Alf thing, and also try and get the raid at least started, so that we can see it actually on the stream.
Yep.
With Alf launching across the screen.
Yeah, I mean, to start with, you could just put in, you could just be that thing, right?
Absolutely, that's what we'll start off with. Okay then, so let's. So thank you everyone for joining. Thank you, DragonEye, Cobase. Just thank you for that. Rambling Geek, if you're still there. Vitol, good to see you. We had Coded Beard, if you're still around. Thank you very much for joining the stream. As you'll remember, everything's up on GitHub, so if you want to go and have a look at that, my GitHub repository is there. So let's go and find someone to raid, shall we? Let's go and find someone to raid. So, the likely suspect.
Stream is a hell of a chat. I never heard of that happening before.
Sorry?
Vitlo says that the stream is the head of chat. That has never happened. It's a head of a chat. The chat is the head of the stream. That I know. Vitlo says that the stream is streaming for the future.
Okay, so we're going to go and raid Source Scoot, I think. We tend to do that quite a bit, but he's a good chap. So let's go and raid him. So where are we?
See, Stephen Wolfram is here streaming.
Oh, is he? Okay.
Is it? I think that is Wolfram, the Wolfram guy. I'm not sure. I never really watched him, but that's cool.
Let's see if Source Scoot's still going. Yes, he is. Let's go and raid Source Scoot. So thank everyone for joining the stream. We'll continue this with the text next time. And thank you, Mårten, again for introducing some fantastic concepts today. Really like the way we have managed to embed the Rocket Alf into that web page, and also we learned a bit about GitHub IO static web pages. So thank you so much. And let's head off to the raid. So do stay with the channel if you'd like to raid Source Scoot, and do paste any emotes you've got into chat as we head over to him. So thanks so much, and I'll see you next Wednesday when we'll be doing some more Z80 emulation work. So I'll see you then. Take care. Well, we do it. That's it. Okay, I'm going to just shut the stream down.
Okay.